We're going to talk about two types of design in research methods, and we're talking about true experiments here, where we're doing not quasi-experimental, not non-experimental, but we're actually doing experimental designs. There are two designs that I want to help you understand better. They are the within subjects design and the between subjects design. And once you get them, it's easy to understand them. But I'm going to demonstrate it by sort of drawing some diagrams and some things on the board that I think will be helpful for you to understand. We're going to focus first on what we call a between subjects design. It's the most common design, and it's the one that most of you are already familiar with. So between subjects design works like this. We do our random selection. And let's say we get and you guys all know what random selection is, we get 100 participants. And then for a between subjects design, let's say we just have two groups, group A and group B. This is our treatment group and this is our control group. For a between subjects design, what you do is you just randomly assign 50 people to this group and 50 people to this group. Now, this is a very common design. It's vulnerable to some of our threats to internal validity that we've already talked about. One of those is assignment bias, right? We don't know how similar these 50 people are to these 50 people. But we assume because of random assignment that they are pretty similar, right? Random assignment is the great equalizer. These people, we should have the same number of males and females. They should have close to the same average age, average IQ, average socioeconomic status, all of those things. We make that assumption, right? And that's okay. This is an okay design, but this is how we do a between subjects design. But I want you to think about it. We have 1 through 50 here, and we have 1 through 50 here. Now, when we do research, we have what we call error variance. We have things that are just noise. They're not due to our treatment, our independent variable. They're just things that exist. One source of that error is the difference between these 50 people, right? They are different people, so they're not the same. So there's just some things that we can't control for. And we also have error variance here. In addition to that, with a between subjects design, we have error variance here, okay? So we have two sources of error between the individuals and the error because these two groups are different collectively. Make sense? So that is a between subjects design. Now, I'm going to contrast that to a within subjects design. I'm going to step right over here. We're going to say this is within. Now, the way you manage a within subjects design is we can randomly select. Have to random select if we're doing a true experiment. But this time, and this is one of the benefits of a within subject design, we only need 50 people. Okay? Because within subjects design, what you do is you have all 50 participants engage in both A and B. We're not going to have 50 different people. By not having 50 different people, what error variance do we eliminate? Do we eliminate this error variance, or do we eliminate this error variance? It's this one, right? Because we still have 50 different people and they're still different, for different reasons, but we don't have two groups. We don't have two sets of error variance. We only have one, okay? So we've eliminated that. Now there are good reasons to use this model and there are good reasons to use this model. But what we don't do when we do within subjects design is we don't have all 50 people do A on day 1 or time 1, and then do B on day 2, time 2, because that sets us up for concerns about internal validity, it may be just going in A causes the changes in going in B. So what we have to do with a within model design is we have 1 through 25, day 1, time 1, and 26 through 50, day 1, T1. And then we switch them around. Day 2, time 2, we have 26 through 50 in A, and day 2, time 2, we have 1 through 25 in B. So there are strengths and advantages to doing the between subjects design, and there are strengths and advantages to doing the within subjects design. For example, if you're doing something with learning or memory, you probably cannot use a within subjects design because being in A will impact being in B. Now, you would think this is what we call counterbalancing, that would solve for that issue, but we've discovered that in learning and memory, it's probably best just to do a between subjects design. But with other questions, depending on what your research question is, if at all possible, doing the within subjects design is more beneficial because we're eliminating at least one source of error variance. All right, so we're going to spend lots of time talking about each model, but I just wanted to contrast the two models for you before we get started.